Hello again. This video is going to walk us through drawing chair flips. And the first thing I want to do to draw a chair flip is to convert this planar drawing into a chair structure. And I want to again stress that when we're looking at this type of a cyclohexane drawing, we should think of it as looking at it from a top-down perspective, where the top is this part that's facing us, and then below the screen, of course, is the bottom of the molecule. When we draw a chair structure, we're going to look at it from a side-on perspective, where the top of the molecule is sort of on the top of our page, and the bottom of the molecule is on the bottom of the page. So let's just write a few notes here. We're looking at the top of the molecule. And if we draw a chair, and if your chair doesn't look so nice, you can always try again. So let's just get some practice doing that. I'm going to erase this chair and give it another shot. Sometimes even the experts need a second attempt. That's a little better. And we want to now add some hydrogens here just so that we see them. We don't forget about them. And I want to add some numbers to this original drawing so that I have some landmarks and I can keep track of where any of the substituents are. So I'm just going to start like this. And it doesn't matter where you start. What's important is that you go in the same direction when you number your chair. And so I'm going to start numbering here. Remember, if we're looking at this chair sort of from the side, I want you to think of this dashed green line as being essentially the axis on which this chair can rotate. And if I were to draw the dashed green line on my original chair, it would be coming out of the screen towards us. There's a green dot in the middle of that cyclohexane, but we can't see the axis because it's perpendicular to the screen. And so I'm numbering in the same direction as I did on my original drawing, and that is important. Okay, so carbon 1 has an up-facing methyl group. So let's put an up-facing methyl group on carbon 1. And it has an up-facing isopropyl group on carbon 3. And so I can draw an up-facing isopropyl group there. I'm going to add the hydrogens at those positions. I'm not going to draw all of them here. That's going to get a little messy. So we have those hydrogens. And again, let's just stress that the bottom of the molecule is below the molecule on the page, and the top of the molecule is up here above on a different, on the top of the page. And so let's do a chair flip. I like to use this little squiggly arrow to indicate a chair flip. And to do that, I need to draw the opposite chair. Most of us have trouble drawing the opposite chair. We're good at one chair, not the other. I'm going to take another crack at that. It's early in the morning. I might need some extra practice here, so let me try again. There we go. And so now I need to observe that, let's just give carbon 1 a red dot. This is also carbon 1 here because when the chair flips, that carbon flips down. The carbon we've identified as 4 flips up. And so now I have my numbering this way. Every up carbon is now a down carbon and vice versa. And so on carbon 1, I can add an upward-facing methyl group. Let me switch back to blue here. And I'm going to put my hydrogen here. On carbon 3, an upward-facing isopropyl group, as well as a downward-facing hydrogen. And so this would be the chair flip. And we can see that anything that was axial became equatorial. Anything that was equatorial became axial. But the isopropyl was up in our original planar drawing. It was up axial in our first drawing. It is up equatorial in our second drawing. It is still up, no matter which perspective we're looking at. And I want to point out one more thing, that you could also draw this using your original chair structure if you prefer that one. okay? But just keep in mind that carbon number 1 needs to be a downward facing carbon, and so this is now carbon number 1. It has to be pointing downward. And so if I number that way, I get these 4 numbers, and I can put on a downward facing, an upward facing methyl, downward facing hydrogen, upward facing isopropyl, downward facing hydrogen, and I need you to convince yourself that these are the same molecule. They're just rotated a little bit along this green axis that I pointed out earlier. If we rotate that a little bit, we can get to this molecule on the bottom. So you can use either chair drawing to draw the chair flip. You can stick with this same sort of perspective if you want to. Just make sure that your numbers move one bond over so that your upward pointing carbon number 1 here becomes a downward pointing carbon number 1.